Have you ever wondered what it would feel like to wake up not once, but twice, every single morning? In tonight's tale, we drift to a real planet where not one, but two stars rise in the sky, casting twin shadows and bathing its world in double golden light. This soft, starlit journey will carry you through curious facts about planets that orbit binary stars, how they might sustain life, and what sunrises look like under two suns. You will learn that planets in these systems can have wildly unpredictable orbits, multiple seasons in a year, and sometimes 3 sunsets in one night. Good evening, friends, and welcome aboard another fact-filled voyage through the cosmos. Tell me, in the comments below, what part of this lovely little planet you are listening from, and what time it is where you are. It always amazes me to think that someone is listening in the glow of morning, while another is already dozing under the stars. Subscribe for more relaxing fact-based bedtime journeys through the stars, but only once you have drifted to sleep, or else the stars may not approve. So take a deep breath with me now. Let it out slowly. Again, this time a little slower. With each breath, let your shoulders fall a little softer, your hands rest a little heavier. Notice the rhythm of your body and let it slow with the universe around you. It is time to ease your mind and relax, as our journey through the universe tonight begins on a world unlike any we know. Our starlit ship floats now toward a system called Kepler-16. Nestled in the quiet constellation of Cygnus, there a planet called Kepler-16b orbits not one, but two stars. Let us call it Double Dawn for short. Double Dawn is a gas giant about the size of Saturn, but its skies are something special. Each day begins with the rising of two suns, one golden and one more orange, like a glowing tangerine. On some days, both stars rise together, casting long twin shadows across the landscape. Other days, one star rises just as the other is setting, painting the sky in shifting bands of pink, coral, and soft plum. Double Dawn does not have a solid surface, but if it did, you would see light ripple and bend in unusual ways. Even though Double Dawn itself cannot support life, its presence tells us something extraordinary. It proves that planets can form and survive in binary systems, something scientists once thought impossible. Binary star systems are more common than single star systems like ours. In fact, over half of the stars visible from Earth are part of a pair or more. Imagine how alien yet familiar a world would feel, where shadows twist in two directions and the sky has no clear noon. If Earth orbited to stars, our temperatures would swing wildly depending on the alignment of the suns. Some scientists believe that such conditions could create wild, chaotic climates with sudden cold snaps or heat waves. Yet, some models suggest certain orbits could be surprisingly stable, making life possible in these curious systems. Let us take a moment to imagine what it would feel like to walk along the shore of a calm alien sea beneath two rising suns. The light would reflect in pairs across the waves, shimmering as though the ocean had twice as many sparkles as it should. Clouds might cast overlapping shadows, stretching out like a pair of sleepy arms across the land. With no solid surface on Double Dawn, we can only imagine, but many other binary systems hold rocky planets that just might. Another planet, Kepler-47c, lies in a different binary system and is thought to be inside what astronomers call the habitable zone. That means it is the perfect distance from its twin stars for water to stay liquid on its surface. If water is present at all, let us call Kepler for 7c Sun Sandwich. Sun Sandwich orbits two stars locked in a gentle gravitational embrace, circling one another every 7.5 days. Sun Sandwich completes a full orbit in about 300 days, which is fairly similar to Earth's own orbit. Because its stars are smaller and cooler than our Sun, the light on Sun Sandwich would feel soft, like warm afternoon sunlight at the end of a gentle spring day. The sky there might not be blue at all. Instead, the atmosphere could scatter the softer red and orange hues, giving the sky a dusky blush tone all day long. On worlds like these, plants, if they exist, might be a shade we cannot imagine. Rather than green, they could be deep red, purple, or even black, depending on how they absorb starlight. This is because photosynthesis, the process that allows plants to turn light into energy, depends on the light's color and intensity. On Earth, plants use mostly red and blue light and reflect green. But under two cooler stars, the energy spectrum changes, and so might the rules of biology. In this way, science invites us not only to wonder but to dream about forms of life unlike any we know. Even the days and nights on these planets are different. Some binary systems produce complex orbital dances, creating patterns where one sunrise comes right after another. In one simulation, a planet experienced sunrise, sunset, then another sunrise, only minutes later, which meant 3 dawns in one cycle. That kind of world would be confusing for a wristwatch, but magical for the sky watchers. Even the weather patterns would be wildly different. With light coming from 2 directions, wind patterns could form unique spiral shapes, crisscrossing across hemispheres like brushstrokes on a galactic canvas. Tidal forces might also behave in strange ways, especially if moons are involved. On Earth, our moon and sun pull on our oceans together, creating tides. Imagine what tides would look like with 2 suns and 2 or 3 moons pulling in different directions. The oceans might breathe like lungs, expanding and contracting with unusual rhythms unlike anything we experience on Earth. Now let us talk about how planets like Double Dawn even exist in such systems. For years, astronomers believed that binary stars would disrupt planet formation entirely. The combined gravitational pull was thought to scatter planet-forming material too chaotically. But telescopes have since shown us otherwise. Not only do planets form around binary stars, they often thrive. Stars like Kepler-16 have their own planets that pass right in front of both stars from our point of view. One such planet, Kepler-16b, is a gas giant roughly the size of Saturn. We will call Kepler-16 the cloudy cousin. Cloudy cousin is cold, dark, and likely without life. But it proves that stable orbits around twin suns are possible. Some binary systems are wide and slow, while others are tight and fast, and yet many still allow for planets to stay stable. Stability is key for the potential of life and for long-term climate consistency. It is almost like the universe has found its own way of balancing what looks chaotic to us. Even when stars dance in pairs, planets can find peace in the rhythm. So far, over 20 binary star systems have been confirmed to have planets in orbit. Some of these planets are as big as Jupiter, while others are as small as Earth. We are learning more with every passing year and with each new telescope we launch into the sky. Some of the most stable binary systems have stars that orbit each other in perfect harmony, like two dancers moving in lockstep through the cosmos. In these systems, planets can circle both stars together, creating what astronomers call circumbinary orbit. That is the kind of orbit Sun Sandwich has, gently looping around both of its parent stars. From the surface, if one could stand there, the sky would be a masterpiece of moving light and shifting shadows. Imagine waking up beneath one sunrise, only to see another appear moments later from the opposite side of the sky. It would feel like time was layered, stretching each day into a ribbon of warmth and light. But not all binary star systems are this gentle. Some pairs are wild, with stars flinging material at one another through intense magnetic fields and flaring loops. In these chaotic pairs, planets have a much harder time surviving. One such system, known as HD 98800, is a quadruple star system with two close binary pairs that orbit each other. Let us call it the juggler. The juggler is so complex that it took years of observation to confirm it even had a disk of planet-forming dust. And yet, despite its complicated setup, it might still be able to grow planets in the quiet lanes between its chaotic cores. This shows how diverse and creative the universe can be when building solar systems. The same ingredients we have around our sun are found in these distant places, just stirred in wildly different ways. When astronomers first discovered planets orbiting binary stars, it challenged everything we thought we knew about how planets form. Now we know that gas and dust can settle into stable rings, even when pulled by two gravitational centers. In some systems, dust rings form beautiful shapes, like spirals, gaps, and waves. These features are clues that young planets might be sculpting the dust as they orbit. It is like watching a painter at work. Except the canvas is light years across and the brush is gravity. One exciting place we look for these signs is in the Orion Nebula, where young stars are still forming their planetary families. Within the nebula, there are several binary stars with planet-forming disks, already glowing in infrared images. These stars are so young that their planets are just grains of dust and ice clumping together into larger pebbles. Eventually, those pebbles will grow into planets, some rocky like Earth, and some gas-filled like Jupiter. Even now, telescopes like the Atacama Large Millimeter Array are capturing images of these disks in stunning detail. By studying them, we can watch planets grow in real time, just as they might have around our own sun billions of years ago. It reminds us that our solar system was once just a swirling cloud of hopes and dust. Binary systems are not just exotic outliers, they are common throughout our galaxy. In fact, more than half of all stars in the Milky Way are part of binary or multiple star systems. That means there could be millions of worlds, like Sun, Sandwich, orbiting twin stars under unfamiliar skies. The search for life on these worlds continues, with new missions planned to study their atmospheres and chemical makeup. One day, we might even catch a glimpse of alien vegetation basking under double light. Some of these planets may have moons of their own, creating whole miniature solar systems within a solar system. Tidal interactions between these moons and their planets could generate internal heat, helping to keep subsurface oceans liquid. That is how we think life might survive on some of Jupiter's and Saturn's moons, even today. The same could be true on exomoons around binary planets. The possibilities multiply with every new discovery. Binary stars may seem like they complicate things, but in reality, they just give the universe more ways to surprise us. More suns means more warmth, more motion, and more beauty. From a storytelling perspective, it is like having two narrators instead of one. Together, they shape a world that is unpredictable but full of promise. And in that cosmic partnership, we find new reasons to be curious and to wonder. Let us take a gentle detour now, toward a planet named Toy 1338b. Let us call it Bubble Loop. Bubble Loop orbits two stars in a system about 1,300 light-years from Earth. It was the first circumbinary planet, discovered by a high school intern working with the National Aeronautics and Space Administration. That delightful piece of trivia adds just a little more magic to this already enchanting planet. Bubble Loop is about 6 times larger than Earth and travels through a sky lit by two stars, one larger and brighter than the other. Because the stars differ in brightness, the planet experiences days that shift from golden yellow to soft orange as each star takes its turn. This shifting light would change how plants grow, how shadows fall, and how creatures, if any live there, navigate their world. Every sunrise would feel slightly different, a blend of familiar warmth and unpredictable rhythm. It would be like living in a poem that changes meter each day. Bubble Loop also gave astronomers a new puzzle. Its orbit is not a perfect circle, but slightly elliptical, meaning its distance from the stars changes during each revolution. This affects the amount of energy it receives, and likely its seasons. On Earth, seasons are caused mostly by the tilt of our axis, but on Bubble Loop, it might be a gentle change in star distance that brings spring, summer, or winter. The rhythm of its climate would be slower and softer, like the swaying of a lullaby. There are binary star systems much closer to Earth as well. One such system is Alpha Centauri, just over 4 light-years away. It includes 2 stars that are quite similar to our Sun, and a third companion star called Proxima Centauri. Let us call Proxima Centauri Distant Ember. Distant Ember is a red dwarf and the closest star to Earth after our own Sun. Astronomers have discovered at least 2 planets orbiting Distant Ember, and one of them is within the habitable zone. This planet, known as Proxima b, might be rocky and Earth-sized. However, Distant Ember is known for its frequent stellar flares, which could make the surface of Proxima b hostile to life as we know it. Still, the idea of a potentially habitable planet so nearby has captivated scientists and storytellers alike. Someday, we might send robotic probes to explore that system and see the sunrise through a triple-star sky. The light from 3 different suns would shimmer and dance in ways that no human has ever witnessed. It would be like standing inside a kaleidoscope of warmth and motion. Binary systems come in many flavors. Some stars are tightly bound and complete their orbits in just a few days. Others are far apart and take centuries to circle one another. The wide pairs create large, stable zones for planets to orbit one star, while being gently influenced by the second. This configuration is called an S-type orbit. It is the opposite of a circumbinary orbit like the one Sun's sandwich has. In an S-type orbit, the planet hugs one star closely, while the second star looms in the distance like a cosmic lighthouse. The changing position of that distant star could shift the night sky across centuries. Entire civilizations might rise and fall before the second sun returns to the same spot in the sky. On such a planet, history itself might be measured not in years, but in the appearance of the wandering star. Imagine a holiday celebrated only once every 400 years, when the second sun rises in the north. These long cosmic cycles inspire deep reflection and awe. They remind us that time flows differently throughout the universe, and in every orbit and sunrise, a new story waits to be told. Let us glide now to a system named HD 98800. Let us call it Star Square. Star Square is a rare quadruple star system located about 150 light-years from Earth, in the constellation TW Hydra. What makes this place truly astonishing is that it contains 4 stars arranged into 2 tight pairs. Each pair dances in a gravitational waltz with the other, forming a kind of celestial square. A planet orbiting within this system would experience a sky with shifting brightness. As stars moved through overlapping orbits, at certain times, all 4 stars could be visible in the sky at once, creating a brightness unmatched by anything on Earth. Other times, one or more stars might be hidden behind another, dimming the day to a golden twilight. If a planet exists within that system, its calendar would not resemble ours at all. Instead of days and months, life there might be structured around the appearance of each star. Every 4th sunrise might mark a new season. With the additional light and gravitational influence, plant life could evolve to be highly adaptive, constantly adjusting to rapid changes in energy. Flowers might open in response to a specific star and close when it dips below the horizon. Animals could have vision attuned to different light sources, perceiving each sun in a separate shade. These adaptations, though speculative, are rooted in how life on Earth responds to seasonal and diurnal changes. It is likely that life, if it exists beyond Earth, would also evolve in harmony with its local stars. In our own galaxy, multiple star systems are quite common. About half of all stars you see in the night sky are part of binary or multiple systems, yet very few of them are close enough to be seen as separate points of light without a telescope. That means many of the stars we call single are secretly dancing with a partner. Even our own sun may have had a sibling star early in its history. Some scientists believe that this long-lost twin might have drifted away billions of years ago. They have even given it an, let us call it, sleepy sibling. Sleepy sibling, if it ever existed, may have played a role in shaping the solar system's earliest days. Its gravity could have influenced the orbits of comets and asteroids. The idea is still under debate, but it sparks the imagination. Imagine a time when Earth had a twin sun, now lost to the vastness of space. A dawn with 2 lights would have changed everything. Shadows would stretch in new directions. Crops might grow differently. Ancient people may have told stories about the wanderer star that once shared the sky. While sleepy sibling is only a theory, it shows how binary stars may be far more important than we once believed. From the tightly bound couples to the distant companions, stars have relationships of their own. Some are volatile and dramatic. Others are quiet and harmonious. The planets that orbit them carry those stories forward, and every new sunrise, whether single or double, adds another chapter. Let us drift our thoughts toward a binary system called Alpha Centauri. Alpha Centauri is the closest star system to Earth. just over 4 light-years away. It consists of 2 main stars, Alpha Centauri A and Alpha Centauri B. There is also a third, much smaller star named Proxima Centauri. Let us call it Little Red. Little Red is the closest star to Earth, besides our Sun. Though small and dim, Little Red has become the focus of great excitement. In 2016, astronomers discovered a planet orbiting it, known as Proxima b. Let us call Proxima b Cricket. Cricket is a rocky planet, slightly more massive than Earth. It sits in the habitable zone of Little Red, where temperatures could allow liquid water to exist. But Little Red is not as gentle as it sounds. It is a flare star, meaning it can erupt with sudden, powerful bursts of radiation. These flares could strip the atmosphere from Cricket, making it less hospitable for life as we know it. Still, the discovery of Cricket proved something extraordinary. It showed that even small stars can host potentially habitable planets, and because Little Red is part of the Alpha Centauri system, Cricket lives in a neighborhood with not 1, not 2, but 3 stars. The gravity in such systems creates fascinating challenges for planetary motion. Planets may orbit one star closely, while others orbit the entire system from farther out. Some orbits are stable for billions of years. Others wobble and shift, like a marble rolling along a warped plate. Simulations have shown that certain paths, called circumbinary orbits, allow planets to loop around 2 stars at once. These paths must be just the right distance, not too close, or they will be flung away. Not too far, or they will freeze. The Goldilocks zone, in this case, must consider the warmth of 2 suns. As the stars orbit one another, their combined light changes across the planet's surface. This can cause the climate to pulse in waves. Daylight might arrive earlier in some seasons, or linger far into the night in others. Rainfall patterns could shift with the movement of the stars, causing blooming cycles that follow a cosmic calendar. Animals might sleep under a sky that never looks quite the same twice. Migrating birds, if they existed, could use star patterns that shift slowly through time, not just across seasons. And people, if people exist, might tell stories about the stars that dance together in the sky. Just as our ancestors used the constellations to guide them, theirs might use the pattern of 2 suns, one for luck, one for strength, one to wake the day, one to lull it back to sleep. Now imagine a civilization that has never seen total darkness. On double dawn, the night might never be truly black. When one sun sets, the other could still glow faintly along the horizon. The stars above would twinkle with less contrast, like pearls lost in a soft lantern glow. This would shape everything from sleep patterns to myth. People might sleep in shifts, waking not to alarms, but to the lullaby of second light. Their dreams could blur between daylight and twilight, always floating between warm colors. Paintings might not use black at all. Writers may have no word for nightfall. In such places, shadow could be seen as precious. A full eclipse when both stars are hidden at once would be celebrated like a rare holiday. That would be their version of midnight. And when true darkness falls, their sky might erupt in brilliance, stars crowding in like guests at a long-awaited party. They might climb towers or sleep on rooftops just to witness every pinprick of light. Some of these stars would be other suns, far away, hosting their own double dawns. Now let us look at another special system known as HD 98800. Let us call it Fourfold Flame. Fourfold Flame is part of a quadruple star system. That means it contains not 2, not 3, but 4 stars bound by gravity. It is a complicated dance of light, mass, and motion. 2 pairs of stars orbit each other, and each pair orbits a common center. Planets in such a system must find very specific orbits to survive. Scientists using the Atacama Large Millimeter Array Telescope once observed dust rings around one of the pairs. That suggests planet formation is possible even among the chaos. If a planet forms in fourfold flame, it could experience wildly shifting light patterns. Mornings might begin with twin dawns from one pair, then soft glows from another across the sky. Temperature would change not only with seasons, but with the location of all 4 suns. There might be golden light in one corner of the sky and pale blue in another. Clouds might glow in patchwork colors, shadows curling in odd angles. The sky itself could resemble a canvas always being Rainbows might have extra bands refracted through the complex hues of mixed sunlight. Creatures living under such a sky would evolve to match its rhythm. Some may bloom only when all 4 suns align. Others might migrate with light, not warmth, and some might dance quietly under the rare hush of night. Let us turn now to one of the most iconic binary systems ever discovered. The system is called Kepler-16, and it hosts a planet named Kepler-16b. Let us call it Tatooine's twin. Tatooine's twin became famous for reminding people of a fictional desert world from the movies. But this one is real. It was the first confirmed planet to orbit to normal stars. Discovered in 2011, it captured imaginations worldwide. The planet is a gas giant, like Saturn, and likely does not have a solid surface. Still, its sunsets would be mesmerizing. Each evening, 2 suns would dip below the horizon, sometimes together, sometimes one after the other. The sky might blush in gold, melt into crimson, then fade into soft purple twilight. Tatooine's twin completes a full orbit every 229 days. That is just a little shorter than Earth's year. Its stars are about 2/3 and 1/5 the mass of our Sun. Because of that, the light it receives is dimmer, but steady. Temperatures are thought to range from below freezing to a mild chill, depending on cloud cover and atmospheric thickness. The planet may have massive storms, driven by energy from both stars. Winds could spiral across continents of gas, painting broad stripes like those seen on Jupiter. Moons orbiting this planet, if any exist, would have some of the most unique views in the galaxy. From one such moon, one might see 2 suns, a striped gas giant, and possibly even auroras. All of this under skies forever in motion. Now let us imagine the passage of time in binary systems. A year is defined by the planet's orbit, but with 2 stars moving, days and seasons grow complicated. On some planets, shadows do not just move, they split. At noon, there may be more than one shadow, each pointing in a different direction. Over time, this would shift how creatures grow, how they hunt, how they sleep. Architecture might evolve to bend or scatter these overlapping lights. Homes might use reflective surfaces to dim one light while embracing the other. Crops might be planted in winding patterns to track the most nourishing rays. And the people, they would live lives of layered routine, waking with one sun, working with both, resting when the weaker one sets. Some might celebrate the rare times both stars align, calling it a day of unity. Others might cherish the brief twilight when neither sun dominates. Even holidays could be based on stellar crossings. The cycles of light would become their clock, their calendar, and their compass. Binary star systems are more than beautiful, they are surprisingly common. Nearly half of all stars in our galaxy are in binary or multiple star systems. That means planets with two suns may not be rare at all. Let us imagine a civilization growing up under two stars. Their myths might tell of twin gods, one fierce and one gentle. Their timekeeping would rely on patterns far more complex than ours. One star may mark the working hours, the other the sacred times of rest. Imagine watching both stars rise, one a deep amber and the other a soft ivory. The world around you would glow in warm gradients instead of sharp shadows. The horizon would stretch in double light, casting long mirror-like reflections on lakes and crystal sands. Even the rainbows on such a world would be different. With two light sources refracting through moisture, there might be twin rainbows at different angles. One might shine with vibrant reds, the other with ghostly blues. This would be the backdrop of everyday life. Children on that planet would grow up learning to track both suns by instinct. Farmers might tell the health of their soil by the angle of double shadows. Sailors would navigate not by stars alone, but by the looping trails of their two setting suns. Painters would be inspired to blend colors in ways we can only imagine. Musicians might create rhythms that follow celestial crossings. Poets would write verses about the moments when both suns kiss the sea at once. These cultures would feel their world's rhythm in their bones. Their calendars would be as much artwork as mathematics. Their sleep patterns might change seasonally, adjusting with the longer or shorter exposure to combined starlight. Dreams themselves could be influenced by such shifting rhythms of light. A sunset might last twice as long, giving time for festivals and quiet reflections. Dawn could arrive in waves, with one sun slowly brightening the hills, while the other peaks from behind mountain crests. It would not be uncommon for someone to wake up in a golden room with one half glowing brighter than the other. Travelers from Earth might take weeks to adjust to such double days, and when storms roll in, two suns would make the clouds shimmer in unusual ways. Lightning might reflect from multiple directions, lighting up landscapes in mirrored flashes. Even nighttime would be a work of art, because if one star sets and the other lingers, twilight stretches on. Stars of the deeper cosmos would peek through slower, gradually appearing as the final sun bows below the horizon. These drawn-out nights would feel like a gentle welcome to sleep, perfect for stories, for music, for fireside thoughts beneath a slowly darkening sky. If people lived on sun sandwich, their circadian rhythms might follow starlight instead of clock time. Shops and schools might open only when both suns are in view. Lamps and lights would be engineered to mimic the hue of dual starlight for comfort and sleep regulation. People might wear special shades or layered garments to filter overlapping light tones. Art on sun sandwich might lean toward flowing patterns and overlapping colors, echoing the light above. Poets might write in verses shaped by the rhythm of orbital eclipses. Children would grow up counting not just moons, but the number of ways dawn could arrive. Festivals might occur when both suns rise and set at the same moment. That moment would feel rare and sacred, like catching a wish with your eyes wide open. It might be called the harmony hour or the second sun's salute. Religions might form around celestial alignments, each worshipping a star for different qualities. Some people might even believe the stars whispered truths through their overlapping light. Navigation would depend on the slow swirl of both suns across the sky, along with their effect on magnetic fields. Scientists living on such a planet might study auroras caused by dual solar winds. These auroras could paint the skies not just at night, but during twilight hours as well. The colors might be unexpected silver, lavender, or even shades we have no name for. These auroras would shimmer like silk draped across the stars. Explorers and nomads might chase them as others chase storms or sunsets. Their vehicles could be powered by solar energy from both stars, charging faster than ours on Earth. Solar panels might be layered or angled differently to absorb the unusual light pattern. Homes would be built with rotating windows or lenses to optimize warmth and visibility throughout the shifting light. Architecture might resemble sundials that bloom or rotate with the stars. Families could gather on rooftops, not for moonlight dinners, but double sunset picnics. Language would evolve to include many more words. For light, where we say dawn, they might have 5 different words each, meaning a specific type of light. Blue night might be a sacred, quiet rarity, something appreciated deeply when both suns are below the horizon. There could be entire professions built around timing nightfall, perhaps called darkkeepers or shadows. These specialists would alert communities when night approaches and how long it will last. Fiction writers might explore stories of long nights and their meanings across cultures. Sleep rituals would become central to society, as night is rare and precious. On such a world, dreams might be treasured more than gold, because when darkness is fleeting, the stars shine as gifts, not guarantees. Constellations would be harder to see, making them more mysterious. Star maps might be passed down in stories and songs rather than printed charts. Young learners might trace constellations with their fingers in the sky. Shooting stars could be mistaken for omens, or messages from the hidden universe beyond the suns. And so, every night would be a soft miracle. Scientists on Sun Sandwich would likely spend their lives studying light, orbit, and atmosphere. Observatories might be shaped like shells, unfolding toward the sky like petals. Rather than one observatory per city, there could be many, each aligned to specific celestial timings. Schools might take students on field trips just to witness a rare single shadow day. Children might build models of their solar system from woven threads, each string representing a path of light or gravity. Libraries would contain maps not just of the stars, but the rhythms of light over centuries. Some of those rhythms might guide agriculture, predicting when both suns will shine strongest for planting. Farms might operate on rotating schedules, shifting crops with the rhythms of dual sunrise and sunset. There could even be plants that only open under the light of both stars together. They might be called twin blooms or binary blossoms. Art might feature glowing paints that change color under different kinds of starlight. Stories passed from generation to generation could center around light. brave souls who seek the exact point where shadows disappear. In homes, light clocks might measure time based not on hours, but the angle and blend of sunlight. Pets might evolve fur patterns that shimmer or darken depending on which sun is overhead. These creatures might nap in sunbeams, with an instinct for which warmth heals best. A common superstition might be that dreams are most powerful when they begin just after the second dawn. Some cultures might believe wishes only come true when whispered during the rare double twilight. Double twilight is when one sun has just set, while the other still glows low on the horizon. This would cast long, diagonal shadows across the land, creating haunting beauty. Storytellers might light soft lanterns during these times to mimic the fading dual light. Music might include instruments tuned to resonate differently under each type of starlight. There could be lullabies sung only during eclipses, designed to echo the quiet hush of shadow passing over sky. Doctors might study how health shifts depending on which sun is dominant at a given time. Entire calendars might be drawn from the interplay of eclipse seasons and stellar proximity. Time would be woven like a braid, layered with meanings beyond simple numbers. Space travelers from Sun Sandwich might struggle with the simple idea of a single sunrise. Their dreams would always include two lights, two shadows, two kinds of warmth. Their spacecraft might be adorned with twin sails, or mirrors that pay homage to the binary stars. If they ever visited Earth, they might call our skies silent, or our shadows lonely. They would gaze up, tilt their heads, and feel that something is missing. And perhaps, in their stories, Earth would become known as the planet of one light. They might imagine we dream less vividly here, where dawn arrives in only one direction. Or maybe they would believe our dreams are more focused, shaped by the singular arc of our sun. Whichever the case, we would surely trade stories and songs. We would offer them our moon, and they would offer us their double dawn. There would be laughter and wonder in the exchange. And then silence, as both sides look up in awe at what the other has always known. Because no matter how many suns rise, it is wonder that truly lights the sky. Imagine building a solar panel on Sun Sandwich. It would need to pivot and bend like a sunflower, always adjusting to the shifting light. Engineers there might create panels shaped like fans or petals, each segment designed to catch light from a different direction. Some devices might even be intelligent, learning the starlight's dance over time and adapting accordingly. Solar energy would be a natural resource, as abundant as wind or rain. Power grids might pulse in harmony with the suns, surging with dual sunrise and softening with twilight. Entire cities could glow gently all night long, fed by reserves collected during double daylight. Street lights might not exist at all in many places, replaced by glowstones powered by light itself. Skylights in homes might be sculpted to refract sunlight into soothing patterns across walls and ceilings. People might measure energy not just in watts, but in rhythms and waves. A traveler from Earth might find it confusing at first, never quite sure where the brightest light will come from. They might carry a hat with a brim that can rotate, shielding whichever sun shines strongest, or sunglasses with lenses that shift shade depending on which star dominates the sky. Even shadows would seem to move in unfamiliar ways. Instead of shrinking and stretching in a predictable arc, they would twist and fold like ribbons on a breeze. Some days would hold two shadows for every tree and every People might play games in which they try to stand in a spot where their shadows become one. Artists might use shadow dances as a form of performance, choreographing their movements to eclipse their own outlines. In such a world, light itself becomes both canvas and brush. At night, telescopes might open like giant flowers, unfolding silently to catch starlight and whispers from deep space. Observatories might float on clouds, anchored by gentle tethers, to capture clear sky no matter the terrain. Scientists could sit in chairs, shaped like hourglasses, tracking twin stars through curved glass domes. Even sleep might feel different under the influence of two stars. Dreams could arrive in layers, like soft blankets stitched together by light and heat. Some people might believe dreams drift between the stars at night, gathering colors and warmth from both suns. They might write their dreams on silk paper and let them float into the air, hoping they reach the sky. Others might speak their dreams to the sea, casting them like pebbles into the tides, pulled by multiple moons. With two suns and multiple moons, sky-watching would be more than a hobby. It would be a necessity for living, where there would follow unique patterns, shaped by the daily duet of warmth and light. Storms might rise unexpectedly, where starlight meets cool currents, stirring wind into spirals and swirls. Rainbows could form sideways across the sky, bridging the space between one star's warmth and another's mist. Some travelers might chase these sideways rainbows, seeking their end for tradition or treasure. And some children might believe that at the end of the double rainbow, a third sun sleeps beneath the sea. Even myths on Sun Sandwich would shimmer with dual meaning, shaped by the power and play of twin stars. Let us imagine the kinds of creatures that might live beneath two suns. They would likely develop ways to deal with constant light, perhaps with layered eyelids or reflective skin. Some might burrow during the brightest part of the day, rising only during the gentler glow of twin sunsets. Others could evolve iridescent scales, designed not for camouflage, but to scatter overwhelming light into cool, shimmering tones. Their sleep cycles would not be based on light and dark, but on temperature and star position. Nocturnal animals might wait for both stars to dip low before emerging, making their nights as precious as Earth's moonlit hours. Plants might grow broad and flat, to soak up all light available, or needle-thin and stacked, to avoid too much exposure. Their colors would be guided by what light is strongest. Reds, violets, even black foliage could be common. If a plant needed to escape excessive sunlight, perhaps it would tilt its leaves like umbrellas or retract them entirely. In some areas, forests might glow faintly with bioluminescence to compete for nighttime attention. In the ocean, creatures could dance in waves of heat and light. Fish might shimmer with patterns that only appear when two sunbeams meet at just the right angle. Coral reefs could be built from mineral layers that respond to twin tides, growing with pulsing rhythms. Some creatures might have two shadows trailing behind them like silent guardians. Others could use their shadows to communicate, stretching them into shapes as messages or warnings. Migratory species might travel not north or south, but between sun zones, where the angles of light feel just right. If birds existed, they might use the stars' motion to navigate, but would have to adjust constantly. Some might even orbit their homes like satellites, keeping track of the stars' paths above them. In cities, architecture would follow the patterns of the sky. Homes might be angled with sun catchers on the roof, built like petals on a flower. Public plazas would shift in color and light throughout the day, designed to encourage rest when the heat was high. Marketplaces might open and close depending on which star shines brighter at a given hour. Calendars could be based on both stellar orbits, with holidays celebrating moments when both stars align perfectly. Festivals would glow with colored lanterns, fireworks, and songs about the sun's first embrace. Clocks might not use numbers at all, but symbols to represent the rise and fall of each star. Children might grow up learning to read light and shadow as easily as language. Education on Sun Sandwich would include astronomy as a basic subject, needed just to understand daily life. Students might learn to predict which shadows would appear where and how to measure time by the length of dual sunbeams. Maps would include starlight zones, with travel guides for the safest or most beautiful twin sunset views. Artists could paint with light-sensitive pigments that change as the sky shifts. Sculptures would come alive throughout the day, revealing hidden designs as shadows move across them. Fashion might be dynamic as well, with fabrics that adjust in color based on starlight intensity. Clothing could shimmer softly during high sun and glow gently under the dim warmth of evening. Homes might have windows that tint automatically, protecting inhabitants from overexposure while still welcoming the dance of twin dawns. Let us now explore how technology would evolve on a world like Sun Sandwich. Solar energy would be the dominant power source, naturally abundant and varied in intensity. Engineers might design dual-directional solar panels that track both stars as they cross the sky. These panels could swivel and tilt in complex patterns, mimicking the movements of flowers that follow the sun. Some power systems might even be tuned to capture specific wavelengths, filtering energy from each star separately. Energy grids would likely be adaptive, balancing input based on which star is higher or more intense at any given moment. Power surges could occur during rare twin zeniths, where both stars align at their highest points. Engineers might harness that energy for special events, charging entire cities with a burst of light. Transportation might depend on solar-boosted vehicles that gain more speed when sunlight increases. Airships could float along thermals created by overlapping sunbeams, sailing gently across the skies like drifting leaves. Space travel would require careful timing, avoiding gravitational turbulence created by the binary star's complex motion. Launch windows might open during stellar conjunctions, moments when their gravitational forces briefly align or cancel out. Navigation satellites would need to adjust constantly, recalibrating for the push and pull of two stellar masses, where the satellites would also be essential, predicting patterns too complex for instinct or tradition. Data models would need more layers, forecasting not only temperature and humidity, but angle and intensity of dual light. Communication systems might use pulses of solar radiation, bouncing messages off the upper atmosphere like sunlight letters. Construction materials would need to resist constant exposure, designed with cooling systems and reflective coatings. Buildings might be coated with thin films that change structure when exposed to different wavelengths, adapting in real time. Greenhouses would have rotating roofs, allowing specific crops to receive only the light they need from a particular star. Farms could be arranged in spirals, matching the paths of the suns to maximize light efficiency. Food would taste different here, plants grown under twin stars might produce sugars or proteins, unlike anything found on Earth. Cooks and scientists might work together to discover new flavor profiles, textures, and aromas, only possible in double sunlight. Artisan bakers might even time their recipes to bake beneath natural starlight, using warmth instead of ovens. Restaurants could advertise twin-touch dishes, prepared with ingredients exposed to both suns during peak convergence. Even timekeeping would be revolutionized. Smart devices might include dual sundials, displaying not just the hour but the identity and mood of each sun. School bells might chime according to the lower star's position, while bedtime is signaled by the dimming of the upper star. Ceremonies might be scheduled based on star phases rather than calendar dates. Weddings could be held during a dual dawn, where two light sources kiss the sky at once. Religious practices might involve facing both suns during prayers or meditations. Poetry and song would reflect the duality of life, love, and light. Language itself might develop special words to describe phenomena unique to twin star systems. There could be words for the glow between sunbeams, or the shape of a person's shadow when caught between two dawns. Children's lullabies might whisper about dancing suns and sleeping stars. Legends could tell of ancient beings who carried each sun into the sky, taking turns lighting the world. In the quiet corners of Sun Sandwich, explorers might study the geology shaped by centuries of double light and shifting tides. Canyon walls could show layered bands of minerals, each tinted by alternating sun exposure. Some rocks might only glow under the light of one star, revealing secrets invisible under the other. Geologists would likely carry twin-lensed goggles, letting them analyze surfaces as each star alters their appearance. Certain crystals could refract each sun differently, splitting their light into shifting rainbows as you turn them in your hand. Caves might form with dual skylights above, beaming columns of light that rotate like celestial clock hands. Glowworms, if they exist, might mimic the rhythm of sun cycles, blinking in patterns to reflect the duality above. Lava tubes formed by ancient volcanic activity may host alien microbes, thriving deep underground, where the suns never reach. Some of these organisms could use chemosynthesis, just like bacteria near Earth's hydrothermal vents. Others might use faint radiation from the twin stars, passed down through porous rock-like nutrients in soil. A subterranean garden might pulse with bioluminescence, glowing quietly in hues never seen on Earth. Imagine a forest of crystal-leafed plants, gently swaying with geothermal breezes. Each leaf tuned to absorb leftover energy from the rocky crust. Small creatures, perhaps jellyfish, might float through this underground air, feeding on spores or drifting nutrients. Their bodies could shimmer with mirrored surfaces, deflecting both heat and predators. Archaeologists on Sun Sandwich might one day uncover relics left behind by earlier life, fossils of shell-like beings that followed the light trails of each sun, structures carved into stone with symbols marking each sunrise or stellar eclipse. These civilizations, if they existed, may have passed down stories etched into rock that could still be read. Interpreters would look for clues in planetary alignment, carbon layering, or cosmic dust trapped in the cracks. Sun Sandwich's distant moons might offer more stories. Some of them may be captured asteroids, oddly shaped and tumbling as they orbit. Others might have thin atmospheres, holding wisps of methane or carbon dioxide. One might even have a subsurface ocean like Europa, hidden beneath a shell of ice. This moon could be covered in jagged ridges, formed by repeated stretching from tidal forces caused by both stars. Let us imagine standing on that moon, looking up to see not one but two suns cradling the sky. They might appear like twin pearls, one slightly golden, the other pale blue. Together they light up the ice in dazzling colors, painting a scene both alien and familiar. The silence there would be profound, broken only by the distant groan of shifting ice. A robotic explorer might land nearby, slowly drilling through the ice to sample the liquid world beneath. Inside, sensors could detect simple organic compounds, or even signs of microbial life clinging to rocky vents. Water currents below would swirl in mesmerizing patterns, affected not only by internal heat, but by the orbital dance above. On Earth, we marvel at the auroras, green and violet curtains swaying in our skies. Here, auroras might shimmer in unexpected colors, forming strange shapes as stellar winds from both suns interact with the moon's magnetic field. Some would resemble wings, others spirals, glowing with a slow, graceful rhythm. Watching them from the icy surface would feel like watching stars perform an ancient ballet. As we drift deeper into Sun Sandwich's story, we turn our gaze back toward the twin stars above. One star may emit more ultraviolet radiation than the other, subtly shaping the evolution of life on its orbiting planets. Creatures may have developed iridescent scales to reflect the stronger radiation from one star while absorbing the gentle rays of the other. Eyes might have evolved to filter specific frequencies, glowing softly under different lighting conditions. On Earth, many animals rely on circadian rhythms tied to our single sunrise and sunset. On Sun Sandwich, those rhythms would become far more complex. A creature might sleep during the first dawn, awaken during the second, and rest again at twilight when both suns vanish. Their internal clocks could follow star shift patterns, guiding them with precision as predictable as our own tides. Insects might chirp in chorus after each star's descent, creating layered symphonies echoing through the alien night. Predators may stalk the glowing edges of each shadow, timing their hunts to the twin sun angles. Plants would open and close at staggered intervals, some blooming for one sun and others for the second. This could create gardens that seem to bloom twice in one day, petals unfolding in gentle waves of color. Farmers on such a planet, if intelligent life had evolved, might track the timing of both stars to cultivate staggered crops. Calendars would need two sets of celestial notations, carefully charting eclipses, star conjunctions, and dual suns. Some cultures might view the suns as celestial siblings, dancing through the heavens in eternal unity. Others might interpret the pair as protectors, guarding their planet from the cold dark of space. Architecture may be aligned not just to one sunrise, but to the average midpoint between both. This could result in doorways and windows placed at subtle angles, casting layered light patterns inside. Imagine waking in a home where two golden beams overlap across your walls in perfect harmony. Artists might craft mirrors that blend both sunbeams into soft glows that feel more like moonlight than daylight. Poets would write of twin shadows and morning skies painted in double light, Even bedtime stories told by alien parents might include tales of star children who chase one another across the sky. Meanwhile, scientists would remain busy. They might send probes beyond the system to study how twin star radiation alters comet tails or solar wind behavior. They could monitor solar flares from both stars, trying to predict their combined impact on planetary weather. With two suns, energy harvesting technologies might evolve far beyond Earth's solar panels. Instead, tall crystal towers might spin slowly, absorbing rays from both directions at once. These elegant structures could resemble blossoms of glass, humming gently as they collect light. Power might be stored in bioluminescent batteries, lighting entire cities with a soft, shimmering glow. Transportation systems may rely on sunlight timing, using intervals of maximum dual exposure to launch sky ferries or aerial gliders. Each technology would need to account for gravitational forces that shift slightly as the stars orbit one another. As twilight drifts across Sun Sandwich, another world within the same binary system rises into view. This neighboring planet may be gaseous, cloaked in thick clouds like Jupiter, swirling with colors shaped by both suns. Its cloud bands might shimmer in silver and coral hues, reflecting the twin starlight in radiant pulses. Astronomers on Sun Sandwich would name it something poetic, perhaps inspired by the dance of the stars. Let us imagine it is called World Cloud because of its constant movement and turbulent beauty. World Cloud would not be hospitable to life as we know it, but it might host floating colonies in its upper atmosphere. If explorers from Sun Sandwich built airships, they might drift among these clouds, gathering energy from the dual sunbeams. Imagine tethered cities suspended beneath vast balloon-like canopies, glowing softly in the dim copper light. Such journeys would rely on precise gravitational mathematics. World Cloud's orbit would constantly shift with the stars, requiring careful calculations to avoid spiraling into the depths. Back on Sun Sandwich, night would arrive slowly, as one sun dips beneath the horizon before the other. This creates a longer twilight, stretching across the sky like a gentle sigh before sleep. The air would cool in stages, with creatures adjusting their rhythms accordingly. Some nocturnal life might stir during the first descent, while others wait for full darkness to emerge. Stars from other systems would begin to twinkle above, though faintly at first, through the lingering red glow. Observers might climb tall, crystalline towers to witness both sunsets from above the lowlands. From such heights, they could track subtle changes in solar alignment, predicting eclipses and solstices with uncanny precision. These twin star eclipses are among the rarest in our universe. Sometimes, one star may pass in front of the other, creating a flash known as a scissor-gay glow. This brilliant event might light up the sky with a shimmer so bright it temporarily outshines the stars beyond. Ancient civilizations might have built monuments to mark these alignments. Stones could be carved to catch the light at just the right moment, casting sacred shadows only twice a year. Children might gather in the fields to watch, holding shimmering discs to their eyes and making wishes. Folk songs would be sung about the stars weaving their golden thread through the heavens. Languages may even have words for moments when both suns reflect off the same lake, creating a perfect halo of light. And just like Earth has solar holidays, these twin star worlds could have celebrations for each sunrise and each sunset. Some communities might feast after the first dawn, others after the second, creating a rhythm of togetherness and rest. Perhaps even bedtime rituals begin when the second star fades, ushering families indoors for stories and sleep. As people drift off, the stars of the greater galaxy slowly blink into view. Orion, the Pleiades, and Cassiopeia may appear differently in the twinlit sky, but their stories would echo through every world. Even constellations may hold new meanings for these observers. Some might be seen only during the shadow of the primary sun, others during the dim glow of the secondary. This dual visibility would offer twice the legends, twice the myths, and perhaps twice the dreams. And in all of this, one truth remains. Across the universe, from Earth to Sun Sandwich, wonder connects us all. On Earth, most of our weather patterns are shaped by the singular pull of one sun. But on Sun Sandwich, the weather is choreographed by two. Clouds might form symmetrical spiral arms like galaxies, guided by solar heating from multiple angles. In some regions, warm air would rise between the suns, while cooler air presses in from the sides, creating an elegant dance of pressure and wind. Storms might rotate in unpredictable patterns, sometimes changing direction mid-rain could fall in bursts of golden mist, each droplet refracting sunlight from two sources. Rainbows, if they form, could overlap or spiral, painting the sky with never-before-seen arcs of color. These rainbows may appear more than once per day, each linked to a separate dawn. Sky watchers would learn to predict them by watching cloud thickness and the exact positions of the suns. At certain times of year, double rainbows might overlap to create an optical phenomenon called a glory ring. These rings would resemble halos, perfectly centered around a person's shadow. Imagine standing on a misty cliff at sunrise, your outline crowned with twin sun halos in the sky. This could be a sacred moment, reserved for rites of passage or personal reflection. Perhaps local traditions include writing hopes into the air with steam or chalk, letting them fade into the next rainfall. Sun Sandwich may also have seasons, though likely more complex than Earth's four-part cycle. Each sun has its own gravitational and thermal influence, pulling the planet's climate into shifting phases. In one season, days may stretch longer and light becomes more intense. In another, the suns align in ways that cast constant twilight across the land. Some years may experience shadow seasons, where both suns are partially obscured by planetary motion, dimming the skies for weeks. During these periods, plants may go dormant, storing energy for brighter days ahead. It is possible that wildlife responds to the rhythms of these twin suns, rather than Earth-style months. Creatures might migrate, not by temperature, but by solar angle or color of daylight. Certain birds could follow the twin sunbeams across the sky, always staying between them for maximum warmth. Their wings might shimmer with structural feathers, bending light in dazzling ways. In the oceans of Sun Sandwich, tides may move not with the moon, but with the twin suns and their relative positions. Each tide could take on a different hue, depending on which sun influences it most. Children might be taught to read the tides like calendars, using them to count down to seasonal festivals. These festivals might involve lanterns, shaped like the suns, drifting across lakes or floating high on thermal winds. People would dress in fabrics that shimmer in pastel hues, echoing the color of twin sunsets. Bakers might prepare sun-shaped sweets with fillings inspired by the colors of the sky. The arts of these cultures would revolve around duality and harmony, sculptures with two faces, songs with mirrored melodies, dances in pairs. Even lullabies would mention both suns tucking the sky beneath their glowing arms. As darkness gently returns, the night offers more than rest. It offers a reminder that light will rise again. The night skies on Sun Sandwich would be a canvas of complexity and calm. With two suns at rest, the stars could sparkle with exceptional clarity in the stillness above. Some constellations might appear doubled or warped by the slight gravitational lensing from nearby binary systems. Observers might map the sky not with one central north point, but to shifting poles aligned with the system's unique orbit. Stargazing could be a treasured ritual, as families gather on hilltops to watch meteors weave between twin star trails. Astronomers on Sun Sandwich might catalogue star clusters differently than we do, focusing on their movement against a binary backdrop. They may even use those shifts to mark time, similar to sundials, but in reverse night-guided clocks. Children might learn constellations with stories that include two suns playing hide and seek among the stars. Poets might describe the stars as gossiping between blinks of the suns. Scientists there may have entire theories shaped by their dual perspectives equations that include variables Earth has never needed. Their calendars may be more circular than linear, looping in figure eights to reflect their world's orbital reality. Villagers may name each day after a phase in the sun's dance. First light, crossing glow, full twin, quiet apex. These names may hold not only poetic meaning, but agricultural and navigational value. Sailors on Sun Sandwich may follow sky maps that shift weekly, using subtle color variations in starlight to guide their way. When the suns are both below the horizon, certain bioluminescent creatures might emerge from forest floors or coral caves. These life forms may communicate in pulsing flashes of light, mimicking the pattern of twin suns. In the distance, mountainous regions could glow faintly from minerals charged by dual solar exposure. Such peaks may be seen as sacred sites, attracting pilgrims during equinox-like alignments of both suns. At those times, the twin dawns may rise perfectly behind the peaks, creating a diamond-shaped gleam through the mountain pass. Wanderers might gather in hushed reverence, watching as the suns appear to split the sky. In the valleys below, farmers may prepare sun-charged soil for planting during these celestial alignments. Some crops may only sprout when both suns are at specific angles, requiring calendars etched in stone or stored in memory. Each planting season may be marked by colorful ceremonies, where seeds are thrown into the wind in celebration of renewal. Artists may dye fabric with pigments that shift hue depending on exposure to different types of sunlight. These garments may carry meaning, pass through families for generations. Scholars might write books with ink that fades under the primary sun but darkens under the secondary. This could serve as a natural form of secrecy, requiring both suns to read the full truth. Children's toys may include twin shadow puppets that change shape throughout the day, encouraging storytelling tied to the rhythm of light. Musical instruments might be tuned using temperature-sensitive strings that vary in tone as sunlight changes. Concerts could be held at sunrise, with sound, light, and shadow choreographed into an experience only a binary world could offer. Entire architectural styles may emerge from the need to adapt to shifting angles of heat and glare. Homes might include movable canopies that track both suns, opening and closing in quiet synchronicity. Over time, these shelters may take on symbolic shapes that represent protection, balance, or reflection. On Sun Sandwich, balance is not just poetic, it is survival. Let us begin to quiet our thoughts. Picture yourself resting on a gentle cloud beneath skies touched by twin dawns. The light fades slowly, as if the heavens are dimming to lanterns instead of one. On this planet, sleep may come not once, but twice in a single day. Living things might rest in rhythms unfamiliar to Earth, guided by the warmth of two setting suns. Homes could have wide windows reaching toward the sky, welcoming each sunset like an old friend. Imagine parents telling sleepy stories of stars that wandered too close to one another and became partners forever. Elders might speak softly of animals that walk between day and night, their lives woven between two different kinds of twilight. And while we imagined these scenes, real stars continue spinning above us. They hold each other in an endless, graceful motion, drawn close by the quiet pull of gravity. Neither star leads the other. They move together in perfect balance, just like the thoughts that drift through our minds before sleep, never in a hurry, never lost. Sun Sandwich is not a fairy tale. It is a planet that truly exists, orbiting two suns in perfect harmony. Its presence reminds us that even in the farthest corners of space, there is peace and balance. We find comfort in knowing that light and warmth can come from unexpected directions. As dawn touches your own window, think of those twin dawns rising elsewhere in the cosmos. That idea alone is enough to bring stillness to a busy heart. The universe has always whispered in quiet patterns and soft glows. It never shouts, because it does not need to. Its stories are told in silence and light. You belong to those stories. As your eyelids grow heavier, imagine the last candle in an old observatory being gently snuffed out. Let your breathing follow the rhythm of a sleeping planet turning slowly in space. Picture yourself drifting just above double dawn, carried gently on a current of starlight. With each breath, you are lighter, calmer, and closer to rest. There is no schedule, no noise, only peace. There is only the golden breath of stars warming your skin. There is only the hush of cosmic winds whispering through imagined trees. And there is only you, floating gently between suns, wrapped in the quiet of deep time. If you are still awake, picture the final moment on Sun Sandwich. A sea as smooth as glass, a sky glowing with soft, unfamiliar colors, twin suns slowly melting into the waves. Their final light sparkles across the water like a lullaby in motion. Then comes night, and the stars open their eyes, each one shining its ancient light across the vast sky to reach you. Each sparkle is a sigh of comfort. Each breeze is a lullaby from far away. Each planet is a cradle rocking gently through the quiet of space. Take a slow breath in. Feel your shoulders drop as if they settle into warm sand. Picture a calm hill under a velvet sky brushed with the Milky Way. Crickets sing nearby, guiding your heartbeat into steady rhythm. Our journey through the universe tonight begins from this gentle hilltop. Look toward Sagittarius, where astronomers spotted the object named Ogle 2016 BLG 1928. Let's call it Lone Marble for short. Lone marble likely weighs no more than Earth's moon. It revealed itself when its gravity briefly brightened a distant star. A fleeting micro-lensing flash. Such flashes last only hours and never repeat, like cosmic fireflies. Surveys hint that starless planets may be 3 times as common as planets that orbit stars. Imagine city streets without lamps, yet countless cats still wander. That is how these worlds drift through space without a sunrise. Now gaze toward Pisces and find the object named PSOJ 318.5338 22.1551. Let's call it Warm Drifter for short. Warm Drifter holds about 8 times the mass of Jupiter and glows near 1100 Kelvin. It spins once every 8 hours, whipping clouds that may rain molten iron. Even so, it journeys alone through endless twilight. Astronomers believe newborn giant planets can fling smaller worlds outward during chaotic early dances. Computer models show a young system may eject more than 3 planets within 100 million years. These fugitives carry hidden oceans under ice, like thermos bottles guarding warmth. Let the thought of secret seas under starless skies settle over your mind like a heavy quilt. Warm Drifter is not alone in the dark expanse. Astronomers have found another rogue, called CFBD SIR 214904003. Let's call it Lonely Ember for short. Lonely Ember glows with leftover heat near 500 Kelvin, cooler than Warm Drifter, yet still warm by space standards. Its atmosphere likely holds methane, water vapor, and clouds of silicate dust. Telescopes measure its brightness, shifting, hinting at patchy weather patterns. No sunrise ever reaches those clouds. Light only comes from the planet's own fading warmth. Now imagine a traveler standing on Lonely Ember. The sky would stay black even at noon. Faint auroras might ripple green and purple across the horizon. Those lights would form when charged particles from space meet the planet's magnetic field. Magnetic fields arise from swirling metallic cores. Even a lonely planet can spark its own light show. Research that makes the galaxy a vast ocean of unseen worlds. Future missions aim to chart these hidden isles. The Nancy Grace Roman Space Telescope will monitor dense star fields for short, micro-lensing pulses. Each pulse could reveal an Earth-sized wanderer drifting between suns. Roman may detect hundreds in a single 5-year survey. Such data will show whether our solar system is typical or tame. Before Roman flies, smaller clues come from nebula rims. Their astronomers find dark gas clumps named globulets. Globulet 1337G. Let's call it Tiny Puff for short. Tiny Puff weighs a few times more than Jupiter, yet spans only 100 astronomical units across. Radiation from nearby massive stars erodes its edges like wind carving sandstone. Inside, gravity squeezes gas until it collapses. A planet may form without a star ever igniting. Tiny Puff will then sail alone through interstellar night. Some globulets merge, making larger bodies that glow faintly in infrared light. Others evaporate before collapsing, releasing dust back into space. These processes seed future star-forming clouds with rich elements. In this way, wandering worlds recycle cosmic material. They act as slow-moving cargo ships of ice, rock, and organic compounds. One theory suggests rogue planets could carry life between stellar systems. Microbes might hide in deep subsurface oceans warmed by radioactive decay. If such a planet passed near a young star, melting ice could release those microbes into new habitats. This idea is called lithopanspermia. At a galactic scale, whether true or not, it sparks the imagination during quiet nights. Let that possibility rest in your thoughts like embers glowing under ash. Our journey resumes among silent rivers of interstellar dust. Cold hydrogen wisps flow like unseen tides around our vessel. Background starlight dims until only faint galaxies remain. We drift toward the constellation Musca. Astronomers observed an object named OGLE 2012, BLG 1323. Let's call it Quiet Pebble for short. Quiet Pebble likely holds just half Earth mass. Its gravitational lens lasted 18 minutes, the briefest on record. Such speed suggests a compact body moving swiftly through the galactic disk. Quiet Pebble may have formed in a crowded system near massive stars. Strong encounters can hurl small planets outward at escape velocity. High-speed wanderers cross vast distances between spiral arms. Galactic tides then tug their paths into long, gentle curves. Some will spend 10 billion years without nearing another star. Despite darkness, internal radioactivity can warm their rocky mantles. Heat drives slow convection that powers weak magnetic fields. These fields shield thin atmospheres from cosmic rays. Surface pressure may equal 1% of Earth's atmosphere. That thin air still carries aurora particles around magnetic poles. Imagine standing on Quiet Pebble under magenta curtains of light. Ground would crunch like frozen sand beneath insulated boots. Sky temperature stays near 3 Kelvin, the same as cosmic background. Heat from within creates tiny frost geysers at polar fissures. Each geyser releases carbon dioxide, crystals that fall like glitter. We leave Musca and aim toward Ursa Major. The Wide-Field Infrared Survey Explorer catalogued WISIA J114724.10 plus 255333.0. Let's call it Fuzzy Lantern for short. Fuzzy Lantern glows in infrared at 400 Kelvin. Spectra reveal water, vapor, and cloudy ammonium sulfide. Its mass is 12 times Jupiter, near the line between planet and brown dwarf. Fuzzy Lantern rotates in 10 hours, producing striped jet streams. Winds there could reach 1,000 meters per second. Storms stack into towering vortices, taller than Mount Everest. Lightning inside storms may forge complex organic molecules. Organic soot then settles, darkening upper clouds. That soot absorbs radiation, slowly cooling deeper layers. Thermal gradients drive more convection and sustain weather cycles. This self-regulating pattern may last billions of years. Such worlds teach climate lessons for exoplanet research. Their isolated atmospheres evolve without stellar influence. We pause amid these facts and breathe cosmic quiet. Let us continue gently deeper into the darkness between stars. We now approach a lonely object named PESOJ 318.5-22. Let's call it the Sleepwalker for short. The Sleepwalker was discovered drifting without a parent star, just 80 light-years from Earth. Its surface temperature is around 1,100 Kelvin. hotter than lava, but still invisible to the human eye in darkness. The sleepwalker is about 6 times more massive than Jupiter. It likely formed in a star-forming cluster, but was ejected by gravitational interactions soon after birth. Because it is so young, only about 12 million years old, it still glows with leftover heat from its formation. Astronomers believe clouds on the sleepwalker are made of molten rock and metal droplets. These clouds swirl across a sky forever black, painted with no sunrise, no sunset. Its atmosphere pulses with chaotic storms that span tens of thousands of kilometers. Wind speeds that may exceed 1,800 kilometers per hour. The planet's gravity is gentle, only slightly more than Jupiter's, so clouds can stack high into the atmosphere. Infrared telescopes have captured light patterns that flicker like candlelight in a cavern. Those flickers may come from lightning and deep thermal waves. Just imagine a world where lightning crackles across iron clouds under a velvet black sky. No star ever rises to bring day. No shadow ever forms. The sleepwalker rotates once every 8 hours, casting storms across its eternal night. It is part of a category called rogue planets. Rogue planets, like the sleepwalker, may number in the billions in our galaxy alone. Some scientists believe there could be more rogue planets than stars. Imagine a galaxy filled with more lost wonders than shining suns. Despite their solitude, rogue planets are crucial for understanding how planets form. Without the glare of nearby stars, their atmospheres are easier to study. Their internal heat becomes the dominant energy source. This makes them perfect laboratories for studying chemistry and weather on gas giants. The sleepwalker might even have moons, tiny frozen worlds trapped in quiet orbit. These moons would see a dimly glowing planet filling their entire sky. They would be locked in constant eclipse, lit only by infrared shimmer. Some might have geysers or underground oceans warmed by gravitational tides. If life could ever exist on a rogue planet, these moons might be its safest harbor. Science fiction has explored such worlds for decades, but now science itself confirms their existence. We are only beginning to map these hidden travelers of the dark. Let us follow where they lead. Gently and without haste, we continue drifting, slow and still, through a galaxy not just of stars but of secrets. We turn our course toward a cold and ancient region of the Orion Arm. Astronomers identified an object called CFBD-SIR 214-90403. Let's call it Chilbill for short. Chilbill is one of the coldest known free-floating planetary mass objects. Its temperature is barely more than that of a pizza oven, around 400 Kelvin, yet it glows faintly in the infrared, like an ember buried in cosmic snow. Chilbill is not very massive, only for 7 times the mass of Jupiter. It likely formed in isolation rather than being ejected. This suggests some rogue planets are born lonely, never tied to a star. The space around Chilbill is remarkably empty. No bright stars disturb its view, only distant galaxies and ancient light. Its atmosphere contains methane, carbon monoxide, and water vapor. These elements swirl gently in slow, cold patterns across a vast surface. Some astronomers believe Chilbill may have auroras. These auroras would be caused not by a star, but by interactions with its own magnetic field. A ghostly green glow, pulsing softly across an endless sky. Imagine standing on a moon orbiting Chilbill, with nothing above but stars, and that pulsing green light. No wind would whisper, no daylight would come, but the view would steal your breath. If you lay back on that moon and looked up, Chilbill would seem to hover, still and calm. Its gentle glow would outline distant galaxies in silhouette. Scientists think the number of rogue planets in our Milky Way may be in the trillions. That is more than the number of grains of sand on all of Earth's beaches. Many of them are thought to have formed in crowded star nurseries. In such environments, close gravitational encounters can send planets flying into deep space. Others may have formed in isolation, like Chilbill, from collapsing gas clouds, too small to ignite into stars. These lonely worlds are sometimes called sub-brown dwarfs. Their atmospheres vary, some rich in hydrogen, others in methane and ammonia. Each carries a different signature of its cosmic history. Rogue planets may also exist in groups, loosely held together by shared origins. These clusters drift slowly through space, like schools of whales through the ocean. No stars, no light, just cold companionship across billions of kilometers. Infrared telescopes, like the Wide-Field Infrared Survey Explorer, have helped reveal many of these hidden objects. Without visible light, we rely on heat signatures to track them. Their warmth tells a story of recent formation, or slow fading over billions of years. Some rogue planets may retain internal oceans beneath thick, icy crusts. These oceans could be kept warm by radioactive decay or gravitational flexing. These seas might contain hydrothermal vents, much like those at the bottom of Earth's oceans. There, life on Earth exists without any sunlight at all, surviving only on the heat and chemicals of the deep. Could the same be true on a rogue planet? We do not yet know, but imagining it opens the mind to strange and beautiful possibilities. Even in darkness, there can be warmth. Even alone, there can be life. And in silence, there can be wonder. We float on now, ever slower, letting these thoughts linger. Up ahead, we find an enormous rogue planet called OGLE 2016b. Big Drift is the lowest mass rogue planet ever detected. Smaller than Earth. It was discovered using gravitational that is when a planet's gravity briefly bends the light from a background star. Gravitational microlensing is one of the only ways we can detect small rogue planets like Big Drift. These events are rare and unpredictable, requiring constant monitoring of the sky. When Big Drift passed in front of a background star, it magnified the star's light for just a few hours. That brief shimmer revealed its existence, like a cosmic wink from the void. We cannot see Big Drift directly, but we know it is out there, gliding alone. It is estimated to be just a few times more massive than the Moon. If you stood on its surface, you might float rather than walk. Its gravity would be so weak that a gentle jump could launch you meters into the air. But the cold would be unimaginable. Without a star, surface temperatures may hover near absolute zero. That is negative 273 degrees Celsius. So cold that atoms barely move. Yet, even Big Drift may hold secrets beneath its icy shell. Beneath thick layers of ice, there could be subsurface oceans kept warm by internal heat. We have seen similar things in our solar system, on moons like Europa and in life on Earth has already proven that sunlight is not always needed. In Earth's deep oceans, Strange creatures thrive without light. They survive on heat and minerals from the Earth's crust. On Big Drift, the same might one day be true. Tiny alien organisms, swimming through dark waters beneath kilometers of ice. They would never see stars or sky, but they might glow softly, using bioluminescence like deep-sea creatures on Earth. Their world would be forever dark, forever cold, yet somehow alive. That possibility is one of the great questions of modern astronomy. Could life exist in complete isolation, far from stars, planets, and warmth? Even if not, rogue planets remain a mystery worth exploring. They remind us that the universe is not always neat. It is messy, surprising, and full of outliers. Some planets never settle into orbits. They dance to their own rhythm. They glide through nebulae, cut through galactic arms, and vanish into the shadows. Big Drift could be older than Earth. It may have been wandering since before the dinosaurs appeared. Over billions of years, it may have passed near stars, moons, and other planets. Each time, slipping past silently. Some rogue planets could even rejoin star systems. A close gravitational encounter might capture them. Suddenly, they are no longer alone. They become part of a new family of planets, circling a new sun. Others may forever drift, untouched and unseen, their stories lost to time and silence. They are reminders of cosmic freedom, unbound by gravity, unwatched by starlight, and unknown to all but the universe itself. They are explorers, silent nomads, ghosts in the galactic sea, and yet, through clever observation, we are starting to find them. Each discovery adds a thread to the tapestry of the cosmos. Even the loneliest world tells a story worth hearing. In this darkness, there is depth. In this silence, there is wonder. Let us coast gently beside Big Drift now, feeling the chill of the void. Its path is silent, steady, and endless. No beginning, no destination, just motion. Let us continue our quiet glide through the starlit dark, following Big Drift's silent passage through the galaxy. No two rogue planets are exactly alike. Some are icy and small like Big Drift. Others may be gas giants, as large or larger than Jupiter. These giant wanderers can generate heat from their massive interiors. Some may even glow faintly in infrared, radiating the warmth of their compressed cores. This glow can make them easier to detect than smaller, rocky planets. In 2012, astronomers found a planet-sized object called PSOJ 318.5222. Let us call it Glowball for short. Glowball is roughly 6 times more massive than Jupiter and floats freely through the galaxy. It is still warm from its formation and glows faintly in infrared light. Glowball was found using the Panoramic Survey Telescope and Rapid Response System. That telescope helps locate faint, distant objects by watching vast areas of sky. Glowball is about 80 light-years from Earth. Despite its distance, its glow revealed its presence. This shows that some rogue planets are still young and hot. They might even have storms and weather like gas giants in star systems. A place like Glowball may have winds faster than any hurricane on Earth. Its clouds could be made of molten iron or silicate dust. These clouds swirl in darkness, never lit by a sunrise. On Earth, the sun powers our winds, our clouds, and our rains. But on global, it is internal heat that fuels everything. These dark giants drift in silence, with their own fierce atmospheres. There may be many more like global. Astronomers believe there could be billions of rogue planets in our galaxy. Some estimates suggest there may be more planets without stars than those with stars. That means the Milky Way might be teeming with invisible travelers. We only catch glimpses of them through rare events and clever observations. But they are out there. Some might have moons of their own. Imagine a moon orbiting a planet that orbits nothing else. That moon would see only darkness, and yet its tides might still shift from the pull of its planet, an endless dance in shadow. The idea of rogue planets challenges how we think about solar systems. It reminds us that not everything follows familiar rules. Some worlds are born in chaos. They are flung from their stars during the early years of a system's formation. Others are stolen by passing stars and cast into the void. Some might even come from other galaxies. Long ago, the Andromeda Galaxy passed close to the Milky Way. Gravity may have tossed planets into new galactic homes. So Big Drift, or global, or any rogue world we find may not be native to this galaxy. There could be visitors from far beyond, galactic immigrants, with stories spanning billions of years. The oldest among them may have formed shortly after the first stars lit up the universe, older than Earth, older than our Sun. These planets carry ancient histories written in frozen crusts and stormy skies, and all the while they drift on, in silence, in darkness, yet never truly alone. Because we are watching, and we are listening, some rogue planets may even host subsurface oceans, just like Jupiter's moon, Europa, or Saturn's moon. Even in the freezing dark, warmth from radioactive decay or internal pressure could keep liquid water below the surface. This means life, in some form, could possibly exist deep beneath the icy shells. Not surface forests or grasslands, but microbes swimming in deep, dark oceans, warmed from below. Think of the deep-sea vents on Earth, where sunlight never reaches, and yet strange life thrives around volcanic fissures. If that can happen here, perhaps it can happen on a lonely, drifting planet as well. These are called eyeball planets. One side may face inward toward a warmer core or tidal heat, like an eyelid Hoffapon. The other remains locked in darkness and ice. The heat differential may cause wild temperature gradients. Storms could rage at the boundaries between hot and cold regions. This might sound chaotic, but in cosmic terms, it is still balance. Even wandering planets can find a kind of stability. Astronomers recently detected signs of possible magnetic fields around some of these worlds. That is important, because magnetic fields can shield a planet from cosmic radiation. Earth has one, and it protects us from solar, wind, and space particles. Without it, life as we know it might not exist. So, a magnetic rogue planet might shelter life better than one without. Some planets may even carry relic atmospheres, thin veils of hydrogen or methane, clinging to the surface despite the cold. Under the right conditions, these atmospheres might trap just enough heat to keep things interesting. On one world called CFB, astronomers believe it might have a young age and a low mass. Let us call it Little Foggy. Little Foggy was found drifting without a parent star, just 100 light-years from Earth. Its youth makes it warm and cloudy. Its clouds could be made of silicates, like tiny floating grains of rock. That gives it a dusty red hue, barely visible in infrared. Little Fogey's temperature might be about 400 degrees Celsius, which is hot, but cooler than most stars. Still, for a rogue world that is warm enough for thick clouds, warm enough for weather, Little Foggy may be a gas planet, much like a miniature version of Saturn, but without rings and with no nearby light. Imagine standing there, looking into a thick, ruby sky. No night, just soft reddish glow all around. No shadows, only stillness. The silence of a planet with no orbit to trace, no seasons, just an endless no. As we drift past Little Foggy, we realize how diverse these wanderers can be. They are not just frozen rocks. Some are hot, some are stormy, some may have oceans, and some, just maybe, have company. One planet called Ogre, E2016, BLG1928, was discovered by accident. Let us call it the Quiet Dot. The Quiet Dot is the smallest rogue planet ever found, roughly the size of Mars. It was discovered using gravitational which watches for the brief bending of starlight caused by a passing planet. The Quiet Dot passed in front of a distant star and warped the light just enough to be noticed. For a few hours, it cast its signature across the cosmos, then vanished again into silence. That is the only sign we have that the Quiet Dot exists. No glow, no light, only the brief memory of a bent starlight beam. This is the challenge with rogue planets. They leave few clues, but even one hint can open up entire new ideas about how planets form and live. Every rogue world we discover makes our universe feel bigger, stranger, and more alive. As we pass deeper into the velvet dark, chasing echoes of planets untethered and dreams unspoken, the way we detect rogue planets is still evolving. They do not emit light like stars, and they do not reflect light from a nearby sun, so they must be found by how they affect other objects, like bending light from background stars. This method is called gravitational microscopy. It requires watching millions of stars over time, and hoping a planet happens to pass in front of one. That is why rogue planets are so elusive. They do not want to be seen. They travel through the cosmos in secrecy. But sometimes, just sometimes, we catch a glimpse. Some rogue planets might even start out in regular orbits. Then something disturbs them. Maybe a nearby planet grows too big and kicks the smaller one out. Maybe a passing star jostles a fragile orbit. Maybe two stars compete over custody and the planet gets thrown away. Once ejected, the planet becomes a rogue, and once a rogue, it is free, no longer bound to any system. It does not orbit anything. It floats endlessly, like a message in a bottle, cast into a cosmic ocean. Over time, many such planets may gather in the galaxy. One recent estimate suggests there could be more rogue planets than stars. That means our galaxy may be filled with unseen wanderers, more planets drifting alone than ones orbiting stars. It is a beautiful, eerie thought. The Milky Way might be one giant planetary playground, but the lights are turned off, and the swings creak in the dark. In the constellation Sagittarius, astronomers found several rogue candidates using powerful infrared telescopes. These instruments can sense heat instead of light, perfect for spotting warm, young planets. One such planet, called PSOJ 318.5-22, was discovered in 2013. Let us call it Lava Nap. Lava Nap is about 6 times the mass of Jupiter. It glows slightly from its own heat, even though it has no star. That glow makes it easier to spot. Its temperature is around 800 degrees Celsius, so despite the dark, Lava Nap is not frozen. It is still cooling from its birth. Astronomers believe it is only about 12 million years old, practically an infant. Cosmically speaking, it is a gas giant, probably with thick, stormy clouds. Imagine the sound of wind there, a wind that never changes direction, because there is no day or night, only rotation and time. It might have lightning storms like Jupiter, but without sunlight, there is no thunder to hear, only distant flashes of light inside a storm that never ends. No sunrise, no sunset, only weather. Forever weather. Now imagine drifting over Lava Nap in a silent glider, the clouds glowing beneath, like amber waves on a midnight ocean. There is no need to rush. There is nowhere to go. That is the lesson of rogue planets. They are not in a hurry. They have no orbit to keep. They simply exist. And sometimes that is enough. One of the strangest ideas about rogue planets is this. Some might harbor subsurface oceans, even without sunlight, if they have thick enough atmospheres or radioactive heat deep inside, then liquid water could exist beneath an icy shell, just like on some moons in our solar system. Like Europa, Enceladus is super intriguing, just like Europa, with its icy surface hiding some amazing secrets. This makes rogue planets surprisingly interesting when we talk about life, because they might offer stable environments, shielded from cosmic radiation and protected from space debris. The heat from radioactive decay in the core could keep water liquid for billions of years, long enough, perhaps, for life to emerge. Not life like ours, but life built in total darkness, evolving by geothermal light instead of sunlight. On Earth, deep-sea creatures live near volcanic vents. They thrive without the sun, so perhaps rogue planets host similar life. In oceans no one has seen, beneath ice thicker than the tallest mountain. This kind of life might be microbial, or it might be strange and complex, swimming through pitch-black oceans, guided only by heat, chemistry, and instinct. And since rogue planets could outnumber stars, this type of dark life might be very common, which is a funny thought, because we always assume life needs light. But the universe does not care what we assume. It just keeps surprising us. Some researchers call these world Steppenwolf planets, after the lone wolf of the tundra, wandering alone, yet full of inner warmth. Steppenwolf planets are not theoretical anymore. We may have already found a few, though proving they host life is another story. Still, they stretch the imagination. They remind us that the cosmos has many ways to build a world, some loud and bright, others quiet and cold, but all equally valid. If a rogue planet passed near our solar system, we might spot it by how it nudges objects like comets, or by its faint infrared heat. Some theories suggest that long ago, our own solar system might have stolen a planet from interstellar space, or maybe it lost one. Some think there could be a hidden planet far beyond Pluto, not bound tightly to our sun, but moving on a strange elongated path. This is sometimes called Planet 9, but no one has seen it yet. It could be a captured rogue, or an original member cast away. If true, it might be 10 times heavier than Earth, an orbit far beyond Neptune. One loop might take 20,000 years, so we have barely blinked since it last passed near us. Whether it exists or not, the search continues, because the story of planets is far from finished. Each one tells a chapter, and rogue planets write the strangest ones, with no stars to bind them, no warmth to guide them, and no rules to follow. They are planetary poems, floating free, waiting for someone to notice, even if that someone is you, listening quietly, drifting softly into sleep. Some rogue planets might not be so lonely after all. There is a chance that some of them have moons, tiny companions bound by gravity, following faithfully through the dark. Even more curious is the idea that some of these moons could also be habitable. Their relationship with the rogue planet could generate tidal forces, just like Jupiter's pull heats up Europa. This heat might keep a moon's inner ocean liquid. Even without any sunlight, these gravitational interactions are a hidden source of warmth, invisible but powerful, and they work in total darkness. This kind of energy is called tidal heating. It stretches and squeezes the moon's interior, generating friction and heat. So even in a starless system, movement alone can keep a world alive. Some simulations suggest that if the conditions are right, a rogue planet with a massive moon could stay warm for billions of years, enough for life to form, possibly even evolve. Imagine a giant, icy world with a thick atmosphere, its surface swept by methane winds, and orbiting it, a glowing moon with frozen mountains and deep, dark oceans. These moons might see their parent planet rise in the sky, a huge, looming mass, bright with reflected starlight from distant galaxies, and perhaps, occasionally, they see bursts of light from supernova, like cosmic flashlights blinking across the sky. These fleeting lights might be the only clue they ever had that stars exist, that somewhere, far away, there is warmth, but they remain in their own orbit, unchanged, alone, together. Scientists have found rogue planets by using gravitational microlength. That is when a planet's gravity bends the light of a distant star, creating a brief, brightening effect. This method does not require the planet to orbit a star, so it works well for finding one. In 2021, astronomers discovered what might be one of the smallest rogue planets ever seen. It may be about the size of Mars, and it might not even be part of any system, just alone in the dark, like a pebble tossed into a quiet lake. Another discovery was made in the Milky Way's central bulge. Thousands of potential rogue planets drifting between stars, possibly ejected during violent planetary rearrangements, just like cosmic luggage that no one claimed. There is a quiet sadness to this idea, but also something poetic, because despite being forgotten by their stars, they still shine, faintly, in their own way. Some astronomers think that our galaxy might be filled with billions of these objects, perhaps even more than there are stars. That means most planets might not be orbiting anything at all. They are the ultimate loners of the universe. And yet, Despite their solitude, they hold stories, histories, in fact, clues to planetary formation. Each one could reveal something about the chaos of solar systems and the balance of gravity. Some of them might be from binary star systems, others from triple star systems, or from stars that no longer exist. They are survivors of stellar drama, of gravitational breakups and cosmic betrayals. But here they are, still rolling through the galaxy, cold, patient, just waiting to be found. Even in darkness, the universe keeps its secrets warm and waiting. Some scientists believe that certain rogue planets might have thick, insulating atmospheres. These atmospheres could trap geothermal heat, creating a blanket against the cold of deep space. On Earth, geothermal heat comes from radioactive decay and residual heat from our planet's formation. Rogue planets may generate heat the same way. Even without a sun, their cores can stay hot, and their atmospheres may trap that warmth. This could maintain surface temperatures high enough for liquid water to exist beneath the surface, possibly in deep underground oceans, shielded from the vacuum of space by thick ice crusts, much like Jupiter's moon Europa or Saturn's moon. And some rogue planets may even resemble Earth in size and density, which would help them retain heat for longer. In theory, life could exist in these subsurface oceans, feeding off minerals and chemical gradients, as life does near hydrothermal vents in Earth's deep ocean. Those vents do not require sunlight, only pressure, minerals, and warmth. That makes them a promising analog. Life on a rogue planet would likely evolve without any knowledge of stars. It might never develop sight, or even the concept of light. Instead, it would feel its way through a black, pressurized world, sensing heat and vibration, moving slowly, gracefully, like whispers through a cave, perhaps with bioluminescent pulses for communication, like fireflies of the deep, and the ecosystem could be stable, unchanging for eons, with no seasons, no solar flares, no sunrise or sunset, just everlasting twilight. There is a kind of peace in that, a life that never knows chaos from above, only what stirs from within. In 2021, astronomers identified a group of rogue planets in a star-forming region called the Upper Scorpius Association. This area is roughly 420 light-years away. Among these planets was a curious one with no name, only a designation. CFHT WIRF98. Let's call it Whisper Drifter for short. Whisper Drifter is estimated to be only a few million years old, a cosmic newborn, floating without a parent star since birth. Its atmosphere contains water vapor, and possibly clouds of iron and silicon. This suggests that some rogue planets may still retain their original atmospheres, at least for a while, though the cold eventually tries to strip them away. Some planets like Whisper Drifter may be hot enough to glow faintly in infrared, making them visible to special telescopes, like a coal that still holds heat in the ashes. If they are young, they might even radiate enough energy to be mistaken for a small star. These are known as planetary mass brown dwarfs. Too massive to be planets, too small to ignite like stars, but warm and glowing in their own right, blurring the line between planet and star, and drifting through space like ancient lanterns, lost but beautiful. Let us ease deeper into the velvet abyss. We follow the faint warmth of distant embers drifting through eternity. The faint glow of some rogue planets can help us understand how they formed. If they are still warm, they are likely very young, and may have only recently been ejected from their systems. Some theories suggest that young planetary systems are chaotic, with large planets shifting positions rapidly. These gravitational shuffles can fling smaller planets into space. Like marbles scattered off a cosmic table, others might form alone in clouds of gas. Just as stars do, but without enough mass to ignite. This means some rogue planets were born as loners, not lost, but never tethered. Their very existence challenges the definition of a planet. Is a planet only a planet if it orbits a star, or is it defined by its size and structure? Astronomers debate this often, because rogue planets blur the lines of classification and invite us to rethink cosmic categories. In 2023, the James Webb Space Telescope studied an object named Wyzia J153429, 75 to 104,303. 3. Let's call it Wobbleboots for short. Wobbleboots is located about 40 light-years away. It is thought to be a planetary mass object without a star. It glows faintly in infrared, releasing heat from its core, and it may have clouds made of molten iron droplets. Yes, clouds of liquid metal, suspended in a thick, dark sky, blown by supersonic winds, tearing across a world without daylight. Imagine walking through that sky. The clouds would shimmer like rusted gold. The winds would howl, but you would hear nothing, because space is silent. You would feel vibration in your suit, but not a sound. Beneath your feet might be hot rock, cooling ever so slowly, like the final breath of a forge, and above you, no sun, no moon, only stars. Forever still, forever watching. It is possible that Wobbleboots was once part of a system. Perhaps it had siblings, or even moons. Now it journeys alone, an exile of gravity. There is beauty in its solitude, a quiet strength in its wandering. Each rogue planet tells a different story. Some were expelled violently, others formed alone in peaceful cradles of dust. Each carries memory in its core, and mystery in its silence. Their surfaces may be frozen, but their hearts may burn with stories, waiting for us to find them. The darkness carries a story waiting to be heard. Scientists believe there may be billions of rogue planets in our galaxy alone, possibly more than there are stars. Some estimates suggest there could be up to 2 rogue planets for every star in the Milky Way. That is a staggering number of worlds adrift, worlds that no telescope has yet seen, each one potentially unique. Some of them may have liquid water beneath icy shells, heated by radioactive decay deep within, much like some moons in our own solar system. Europa and Enceladus, for example. If those moons had been ejected, they might still host subsurface oceans. That means life might exist even without sunlight. Life warmed by geology instead of starlight. Microbial life could evolve in warmth from within. It would never see the sky, but it might thrive in darkness. Imagine bioluminescent life glowing under ice, guiding itself through pitch-black seas, using only internal light. These worlds might be invisible to our eyes, but not to our imagination. Some researchers think we might detect rogue planets through when they pass in front of distant stars, they bend the light. This creates a brief flash, a signature of a hidden world. Like a ghost stepping between us and a candle, the light changes just enough for us to notice. That is how some of the first rogue planets were found. Tiny distortions in starlight, telling of massive objects moving in front. Each flicker a clue, each flicker a whisper from the dark. Some astronomers are building missions specifically to search for more. Future space telescopes may scan star fields, waiting for the quiet blink of a rogue planet drifting past. These instruments will have to be incredibly sensitive, because the signal is faint and fleeting, but the rewards may be tremendous. Entire catalogues of worlds without suns, each one a mystery in motion. Some might be gas giants, larger than Jupiter. Others could be rocky and Earth-sized. A few may even be icy giants like Neptune, drifting endlessly through galactic space, unseen until their gravity gives them away. The next generation of space observatories may find hundreds more, perhaps thousands. We may even find one surprisingly close, a wandering neighbor in our galactic backyard, waiting to be discovered, waiting to be understood. In 2023, a team of astronomers detected what might be the closest known rogue planet to Earth. It was found using data from the European Space Agency's Gaia mission. The planet's full name is Gaia, DR3 4373 4653 524 153 016 32. Let's call it Sneaky Pete for short. Sneaky Pete may be less than 100 light-years away. That is cosmically close. If confirmed, it would be the nearest known world without a sun. An orphaned planet hiding in plain sight, just wandering silently past our neighborhood. Its exact nature is still being studied, but it reminds us that rogue planets may be closer than we think. Sneaky Pete may not be alone. There could be others lurking just beyond our current detection limits, waiting for technology to catch up, waiting to be noticed. Some rogue planets may even retain a tiny moon. If they were flung from their systems gently enough, a moon could remain gravitationally bound, following its planet through darkness. Like two castaways holding hands in the night, that moon might reflect any faint infrared heat the planet gives off, creating a tiny glow in the cold, enough for a future telescope to detect. Astronomers hope to learn more about these possibilities with missions like the Roman Space Telescope. That mission will have incredible precision. It may uncover hundreds of rogue planets through macrolensing by watching millions of stars at once, looking for those faint, momentary flickers, each flicker a possible planet, each one a tiny miracle of chance and alignment. Even with no sun, a rogue planet may still glow faintly in infrared light, especially if it is still young and warm. Some of these might be just millions of years old, still cooling from their birth, radiating heat into the cosmos. These young planets are like coals drifting through space, not visible in visible light, but detectable with the right instruments. NASA's James Webb Space Telescope is especially good at seeing in infrared. It might one day capture light from one of these rogue worlds, allowing us to study its atmosphere. If it has one, scientists are eager to learn whether rogue planets retain atmospheres. Without a sun, They have no solar wind pressure that might help preserve their outer layers. Or, without magnetic fields, they might lose gases over time. Either way, each rogue planet is a case study in survival, a lesson in how planets endure isolation, and how they evolve far from starlight. As we drift to the close of our journey, you may still feel the quiet of those wandering worlds echoing through your imagination. Planets adrift, alone but not lost, silent travelers with no need for sunlight. Some larger than Jupiter, some only the size of Earth, all of them casting no shadow, but still full of stories, still full of mystery, still part of the same universe you and I are in tonight. Perhaps one of them is passing above you right now, invisible to the eye, but very real and very patient, waiting quietly in the dark, waiting for someone to wonder about it, waiting for you to imagine it. And now you have met rogue worlds with no suns. You have drifted past Sneaky Pete. You have floated by volcanic giants and quiet icy loners. You have imagined warmth without sunlight. You have seen storms with no lightning. You have felt the peace of a planet that has nothing to orbit, just itself, and perhaps a moon or a whisper of wind. You have floated through the coldest places in our galaxy, and you are still here, still warm, still safe, still dreaming. Let the thought of those planets rock you like waves in a starlit ocean. No traffic, no time zones, no alarms. Only the hum of gravity. Only the soft silence of interstellar snow. Only the swirling shadows of gas and dust. Let your breath fall in line with their silent orbits. Let your body feel weightless, like it belongs among the stars, because tonight it does. You have traveled far, beyond sunlit worlds, beyond glowing rings and sparkling moons, beyond what most ever imagined before falling asleep. And now it is time for sleep to find you. Like a planet with no sun, you need no light to shine. You carry your own glow, softly, steadily, quietly now, my friend. Let the story fade like starlight behind you. Let the campfire crackle gently from the faraway shore of a forgotten planet. Let the shooting stars pass without need for wishes. There is nothing more you need tonight, just rest and peace and space to dream. I will be here again tomorrow with more stars, more stories, more wonders. But for now, drift off, float free, and let the universe hold you. Good night.